Hey Miss Petro, this is my video on our lab, the intermolecular forces. And just to recap, the intermolecular forces are the forces which are acting within the atoms or the molecules, and they are responsible for many of the physical properties that we see. In this experiment, we tested three different physical properties, that being the surface tension, the temperature change, and the evaporation rate. Now the first part that I will be discussing is part one, where we're looking at the surface tension, and that was tested through the vortex and the dropping of the liquids. Now these are the three substances that we were using in this experiment, that being water, glycerol, and the isopropyl alcohol. Now these are just their structures, so from the structures we're able to gain a sense of what type of forces are acting within. For example, in the isopropyl alcohol, we are aware that there are hydrogen bonds as well as a small little bit of dipole-dipole forces between the oxygen and the hydrogen atoms, as well as there's obviously your London dispersion, which is within each. In water, you have dipole-dipole, as can be seen here, and in glycerol, again, you have the dipole-dipole forces as well as hydrogen bonding again. Now, the three unknowns were basically A, B, and C, which our group was able to determine was A was the isopropyl alcohol, this B was water, and C was glycerol. Now, of these liquids that we tested, we found that glycerol was displaying the greatest surface tension, and I'll show you why. When we were conducting the experiment, we were testing to see which substance would provide the largest vortex or the smaller vortex. This is substance C. Okay, so this is C spinning. And as you can see, as my voice was also telling you, it just stops. This means that it has the highest surface tension, and this is due to the intermolecular forces that can be seen within the structure. We see that glycerol has the most forces acting within it, with three sets of hydrogen bonding as well as dipole-dipole forces. And the more dipole-dipole forces, the greater the surface tension will be. A higher surface tension would also be expected from liquids that have a higher net polarity. And as there are more dipole-dipole forces going on in glycerol, there is therefore a higher polarity. Now, of these substances, I can also determine which one will have, for example, a higher boiling point or will have a lower boiling point just by looking at the structures as well. I could see that from glycerol, we know that it's going to have a higher boiling point, or the highest, because of all the various intermolecular forces that it has. As we've known from class, the more intermolecular forces there are within a substance, therefore the higher its boiling point will be. The second highest would most likely be water. This is because of the hydrogen bonding and the dipole-dipole forces which are within. And then last would come isopropyl alcohol. Now this would be a bit more apparent when we look at our second test that we did when we were doing surface tension, that being the one with the droppers. Now take a look when we're dropping A. This is A right over here. Now when we dropped it, it dispersed, as can be seen here. It didn't form a little lump or it didn't retain its shape. It just dispersed, therefore showing that its forces were much weaker. When we compare it to, for example, B, which we were able to determine was water, it was able to retain its shape as well as still maintaining a little bit of flexibility, showing again how the forces are playing a role. When we compare this back to our structures, we know that water does have stronger forces versus the alcohol, which is why the alcohol was able to disperse. We believe that because it was able to disperse so quickly, and thus proving that it has lower amount of forces, it will therefore boil the fastest. Now let's move on to part two, which involved the testing of the temperature changes between the two substances, ethanol and glycerol. Now we've seen glycerol structure, that being this one. Now let's look at ethanol structure, right over here. So we see ethanol also has the dipole-dipole forces as well as the hydrogen bonding around it. Now these were the results from the experiment, and this is how the chart looks, or sorry, not the chart, the graph looks like. As we can see, it is the green line which shows the greatest temperature change. Now we were able to determine the green line to be ethanol. The reason being, when we look at the structure of ethanol, we notice that it only has a few intermolecular forces, that being the hydrogen bond and the dipole-dipole. Now let's look back at the glycerol. Do you see how many intermolecular forces there are? There are 3 different OH bonds, as well as the hydrogen bonds around it. Because there are more bonds, as we discussed earlier, it will therefore have a higher boiling point, meaning that its temperature change will be lower. Now let's look back to the graph. We think that this is glycerol, again, just because of the intermolecular forces that I just went through. And this is ethanol because when we look at ethanol structure, much less forces going on. That's because there's only one dipole-dipole force and the hydrogen bond. And if you remember back in class, we did that demonstration where we learned that the molecule which has the less amount of forces is going to be able to run away the fastest, therefore causing the greatest temperature change. Now when we look here, we notice that it goes up and down and it excels extremely high. And we believe that this is because of its ability to separate really fast. And now finally on to the last part, part 3. This is where we were testing the evaporation rate within the 3 substances, that being methanol, isopropyl alcohol, and pentanol. Now these are the results labeled here on the chart, and we were able to decipher the colors and the substances to be blue being methanol, the red being pentanol, and finally the last one is the isopropyl alcohol. We were able to come to this decision by looking at what affects evaporation rate, and that basically really is just the molar mass. Now let's look at the structures. This is the structure for methanol. Because it has a far less molar mass in comparison to the rest, we were able to decipher that the blue line was going to be this because it had the fastest evaporation rate. Let's look at pentanol. Because it has such a great molar mass in comparison to everything else, this is why we were able to decide it to be the red line. And finally, when we look back at our isopropyl, it only has the 3 carbons and less additional elements attached to it. Therefore, it had a smaller molar mass than the pentanol, but still greater than the methanol, making it the brown line, which was basically in the middle. Now, another factor which affects the evaporation rate is also the size of the molecule. Take a look at methanol. Let's go back. Not only does it have a small molar mass, but also has a small overall structure. Therefore, it is able to separate faster and run away, as we learned from our demonstration before. Now, when we compare pentanol structure, it has 1, 2, 3, 4, 5 carbons, therefore lengthening its structure and making it much larger versus the alcohol, where it only has 3 carbons. Now I just want to summarize our findings and kind of put it all in perspective for us. In the evaporation rate, we know that it's impacted by 3 things, that being first, the amount of intermolecular force, the molar mass, and finally the overall structure. And that's pretty much it. This was it was cool to see how the forces cause changes in the physical properties, and I hope you enjoyed listening. Bye!